Okay, this is a discussion on error, specifically error in an alternating series. You may recall that when we find a Taylor polynomial or a Maclaurin polynomial, we're approximating the function using polynomials. So the question becomes, how many terms will I need to reach a certain level of accuracy? Or how much accuracy do I have if I use 4 terms or 3 terms? So that's what we're trying to find. How much error exists in our answer? And to do this, what we're going to do is we're going to look at, if the series is alternating, we're going to look at the next term, because the amount of error present is always less than or equal to the next term in an alternating series. So just to give a quick example of this, we can see that this series is alternating, and the series is 1 over n factorial. So to put it simply, if I were to write the terms for this series, it would be, get a pen. The terms for this series simply would be, we're starting at n equals 1, so the first one would be positive, so it would be 1 over 1 factorial minus 1 over 2 factorial plus 1 over 3 factorial minus 1 over 4 factorial. So I wanted to use the first terms. Now, because this is alternating, the amount of error present is going to be less than the next term. So the amount of the next term would be 1 over 5 factorial. So the amount of error present would be 1 over 5 factorial, which is 1 over 120. Now, sometimes I want to know, I want to know how many terms do I need to get a certain level of accuracy. So if I want to get a 2 decimal place accuracy, and I know that to be 0.005, then what I need to do is I need to figure out how many terms do I need to get less than 1 over 200, because 0.005 is 1 over 200. So I would have to say the next term that I have to use has to be less than 1 over 200. Now I'm going to cross multiply that. And there's no way to solve that other than just guess and check. There's no algebraic way of solving this. We just have to remember that n has to be n is an integer. So just guessing and checking, if I guess n is 4, 5 factorial is not greater than 200. So if I try 6 factorial I think is 720. So with 6 factorial, I'm greater than 200, so I'm golden. So I need 5 terms. Okay, let's do another example. So once again, if I were to write the first 4 terms of this, starting at n equals 1, so my first one would be positive, I get 1 over n squared. I'm sorry, well in this case n is 1, so this is 1 over 1 squared minus 1 over 2 squared plus 1 over 3 squared minus 1 over 4 squared. Okay, so those would be my first 4 terms. So if I want to know the amount of error in the next one, it would be less than the next term squared. In that case, that would be 1 over 5 squared. And again, I'm taking the absolute value of that because that's the formula. It's always the absolute value. So now I want to do the same thing I did before. I'm trying to determine how much error I need for 2 decimal place accuracy. So once again, what I'm going to do is do 1 over n plus 1 squared, because n plus 1 represents my next term. Cross multiply. N must be an integer, so I guess and check, and I get n is 14. So now we want to find an upper bound error for if the sum of the first 4 terms used is an approximation. Okay, so we're using the first 4 terms. So that would be, the first term would be negative 1/5 plus 1/5 squared minus 1/5 cubed plus 1/5 to the 4th. I'm using the first 4 terms. So the next term would be 1/5 to the 5th. So the amount of error present has to be less than the absolute value of this. And again, to find the smallest, to find the number of terms I need to get a 2 decimal place accuracy, I'm going to do 1/5n plus 1 has to be less than 1/200. Cross multiplying and guessing and checking. Yeah, I know I could use logs to solve that, but I could also guess and check because remember it has to be an integer. So I choose n is 3 because that'll give me 5 to the 4th, which is 625, and 5 cubed is 125, so that wouldn't be enough. All right, here's a problem from homework. And I might have to pause this because I need a calculator. Just remember that. But what we want to do is we're approximating the natural log of 1.2. Okay? So, and it's centered at x equals 1. So what we have to do is write a Taylor polynomial for the natural log of x centered at 1. Okay? So we start by finding f. So f of x is natural log of x. And f of 1 is 0. So f prime of x is 1/x. So f prime of 1 is 1. F double prime of x is negative 1/x squared. So f double prime of x of 1 is negative 1. And the third derivative would be positive 2/x cubed. So the third derivative of 1 would be 2. So notice when I write this, I have an alternating series. So my first term would be, and it's centered around x equals 1. So my first term would be x minus 1. Minus x minus 1 squared over 2 factorial plus 2 times x minus 1 cubed over 3 factorial. Okay, so if I were approximating the natural log of 1.2 using this polynomial, this third degree polynomial, it would be x is 1.2, so it would be 1.2 minus 1 minus 1.2 minus 1 squared over 2 factorial plus 2 over 3 factorial. I'm just going to write 0.2 because I'm running out of space, cubed. Okay, so I could approximate that. So I want to know how close is that to the actual value of the natural log of 1.2. So to find out how close that is, excuse me, what I would have to do is I would have to use the next term. Okay, so I would use the next term. So if I come down here and I found my fourth derivative, I see my next term is negative 6x. Negative 6 over x to the 4th. So my fourth derivative would be negative 6. So the next term in that series would actually be negative 6 x minus 1 to the 4th power over 4 factorial. This is my next term. This is my error has to be less than this next term. So my error, and again, I'm sorry about this, has to be less than the absolute value of negative 6, and x in this case is 1.2 minus 1 to the 4th over 4 factorial. And I don't remember the answer, but it's on there. I think it's A. Just a second. I don't have my calculator, but let me grab the answers. And the answer is A. No, B. So the answer is B. And that sign there is actually not there. It's 0.0004. Okay, that is my answer. Okie dokie. Your homework assignment is the alternating series day 1 error. And it's 10 problems, and the answers are included. So have a great day, and come back for the video on Lagrange.